Boy, it's a great day to be out and about.
Don't let this happen to you.
The Eclipse shielding system is designed to block glare and sunlight locally, without obstructing your view and without any moving parts. Eclipse detects strong light sources and calculates their position with respect to the driver. Then, using a grid of smart glass variable opacity elements, light is blocked at just the right spot on the windshield. The system will account for different driver sizes, moving lights, driving at night, multiple light sources, and much more. Let's get into the details of our modules and how they work. PDLC tinting control. PDLC film is used to block the light. PDLC film is an electrochromic film that stands for polymer dispersed liquid crystal. Similar to liquid crystal technology, the molecules of this film align with an electric field, allowing the film to be transparent. A lux camera was used to test the relative luminance between on and off. In outdoor testing, PDLC reduced the luminance at least as much as sunglasses, well outperforming our specification. Light tracking. Eclipse uses sophisticated image processing. The images are taken with a fisheye lens, which are then corrected, and a thresholding method through OpenCV is used to identify light sources. To test this system, light was shot from various angles. On average, the detection angle accuracy was better than 1.6 degrees. Driver tracking. OpenCV eye detection through a neural network Haar cascade, coupled with an ultrasonic sensor, was used to find the location of the eyes in 3D space. An accuracy of up to 0.5 centimeters was reached with an update frequency of well over 2 Hz in any lighting conditions. Integration performance. The old testing platform had 20 centimeter tiles and was able to detect multiple light sources, a moving driver, and a stationary light source within a detection accuracy of 30 centimeters. Upon PDLC grid validation, all parts of the project were upgraded for optimization. This is how we optimize our system. Let's talk about the grid manufacturing of the PDLC film. For our design, the film was cut to a depth of 300 microns with a precision of 100 microns. The result was a grid of separated capacitors of ITO transparent conductor. This level of precision required the use of laser cutting and an extensive calibration process. To allow for laser cutting, the film was also separated into 60 by 30 centimeter quadrants, which are individually addressed via bus bars on the ITO layer. The bus bars were connected using silver paste and copper tape, which was then soldered and routed through the windshield to the solid-state relays. Rigging and electronics. Using an I2C GPIO port expander, we can exceed the nominal amount of Raspberry Pi outputs to control 12 single-pole double-throw and 24 single-pole single-throw solid-state relays. The rigging is used to make sure all the parts in the Eclipse system align properly. The new rig is aligned to the frame of the windshield to improve the camera calibration, ease of access, and footprint of the entire system. Control system. From the new optimized and parallelized code, which controls the entire Eclipse system, the light tracking, driver tracking, and grid addressing modules all run on separate processing threads. Glare source locations are calculated on 2 separate microcontrollers, and to improve accuracy, one feeds into the other via serial communication. Then, the optimal spot of the windshield is calculated and blocked. To meet our optimization requirements, the system must block glare within 20 centimeters of the correct spot on the windshield, block glare moving on the windshield up to 1 meter per second, and respond to glare within 1.5 seconds. The results give a stationary source blocking within a 30 centimeter accuracy, able to account for a moving driver, multiple light sources, and moving light sources.
Eclipse. Bring your comfort to totality.
If you have a dream, don't bury it, don't be afraid to focus on it, because that's where you will find you make the best contribution to society.